Okay, 6.4, we're talking about factoring polynomials where the lead coefficient is not equal to 1. So this is something we also talked about a bit in 6.3, and I talked about it a little bit in class, but this is going to be sort of a more structured way to approach these. So I have my polynomial a x squared plus bx. So b is always the coefficient of the x, and then the last number is going to be c, and that's always going to be the constant. And so this is often called the AC method because it uses a special number we get using A and C. So if you've tried to do any of these using guess and check, you know that this is definitely a more difficult type of problem to attack. So yeah, I think this will help. So first of all, and this should always be your first step in any factoring problem, if there is a GCF, factor it out. So if there is a greatest common factor, factor it out. And you can get yourself into kind of a lot of trouble if you don't do this because you just end up with a much more difficult problem than need be. So the next thing we're going to do is find this special number AC. So find the number AC, and that's going to be the product of the lead coefficient and the constant term. And then we're going to use that number in this next step. We need to find two numbers that multiply to that AC. So find two numbers that multiply to whatever A times C was and add to B. And now the thing about these problems where my lead coefficient is not equal to 1 is I'm not done there. I just can't take these two numbers and put them in the second places in my parentheses. But what I can do is this. I can then rewrite that middle term. So rewrite the bx term as the sum of the two numbers found in step 3. So I'm going to do an example. Okay, so first of all, I look at this. My lead coefficient is not equal to 1. I'm going to see if there is a greatest common factor, and it turns out there isn't. So step 1, I checked for a greatest common factor. There is no GCF. So then I'm going to go through and I'm going to find this number AC. So 2, A is 2, B is -6, so my AC equals -12. And now step 3, I need to find two numbers that multiply to AC. So I need them to multiply to AC. So -12. And then I also need them to add to b, and what my b is equal to here, the coefficient of that x, that means my b is -1. So now what I'm going to do, and so there's still some guessing and checking in this method, because what I'm going to do is just look at a bunch of numbers that multiplied at 12, but instead of doing the whole FOIL thing, I'm just going to see, I'm just going to look at whether or not they add to the correct thing. So for example, let's see, -12 times 1 equals -12, and -12 plus 1 equals -11. So that didn't work. And this is exactly the same kind of thing as the other guess and check stuff we've talked about. I want to see these wrong guesses. So I'd love to see a chart of like incorrect guesses, because that means you've been trying this. You can't just try. You have to let yourself have some wrong guesses. So these aren't working, but that's okay. I'm making progress. 4 times -3 is -12. 4 plus -3 is +1. And just like the stuff we talked about in 6.2, if I ever am in this situation where this is really, really close, but it isn't quite what I want, if I just switch the signs, if I make this -4 times +3, that's still -12, but -4 plus 3 is -1. So now that is what I'm looking for here. So this is what I wanted. My two numbers are -4 and 3. So now I have step 4. And what step 4 says is I take my polynomial, which I'm just going to write again here, 2x squared minus 1x, so just minus x, minus 6. And I'm going to rewrite that like this. I'm going to rewrite that minus x as minus 4x plus 3x minus 6. And that might seem like a weird thing to do, but the idea is if I do this correctly, if I find these numbers that add to the thing I want and multiply to the thing I want, I absolutely will be able to factor this by grouping. So I'm going to look at these two terms. These two terms have a GCF of 2x. I'm going to look at these two terms, and these two terms have a GCF of 3. And so I'm going to do that grouping factorization. And I have 2x times what's left. I have x minus 2. And then I take a positive 3 out of here. And what's left if I take 3 out of 3x is just x. And if I take 3 out of minus 6, I just have minus 2 left. Now I have a common binomial factor of x minus 2, so I can bring that x minus 2 out front. And what's left in my parentheses then is this 2x and then plus 3. And that is my fully factored answer. So this is my answer. And so that is the AC method. I'm going to do a couple more examples. And this takes some practice, so make sure you really work on this a bit. I'm going to check this using FOIL just in case you don't believe me. I'd have my fronts, x times 2x is 2x squared. My outers, plus 3x. My inners, minus 4x, minus 6. So it does check out. It works. Basically what this method is about is figuring out a way to break this middle term apart to separate it into the outers and the inners. And it doesn't matter that these are in a different order. As you can see, it does work out to being exactly the same. Okay, let's take a look at some problems on page 2. Okay, here we are on page 2. We're going to look at a couple more examples. So here, once again, I'm going to look for a GCF. Again, there is no GCF. Now I'm going to find those two numbers AC. So step 2, my AC is 3 times negative 1. So my AC equals negative 3. And now I want to find two numbers that multiply. Multiply to negative 3, and I want those numbers to add to my B. So negative 1. So I'm going to go through and try to find some different numbers. So like negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Now 3 is interesting because there's only so many things that multiply to negative 3. And 3 and negative 1, negative 3, and that's it. So 3 plus negative 1, that equals positive 2. So I tried every single thing that could possibly multiply to negative 3, and none of those things add to negative 1. So because none of these worked, I can say that this polynomial is prime. And what that means is this polynomial cannot be factored. The thing that's dangerous about polynomials being prime is what people often want to do on a test is just say that every difficult polynomial is prime. So be aware, it can happen that they're prime, but if you're taking a test and you're getting like a lot of them are prime, like probably I wouldn't put that many prime ones on an exam, So generally, if you're going to say something is prime, make sure you show me some evidence. You need to be really, really sure that it actually is impossible to factor and isn't just difficult to factor. So here's another one, and this is a good example, I think, of one that takes some more time to get figured out. So once again, it would be great if there was a GCF, but there isn't. Step 2. Now my AC, my A is 8. My C is 3. So my AC is 8 times 3 is 24. And now I need numbers that multiply to 24 and add to negative 10. Okay, so I don't know, a bunch of things that multiply to 24. 8 times 3 is 24. 8 plus 3 is 11. So that didn't work. 6 times 4 is 24. 6 plus 4 is 10. 12 times 2 is 24. 12 plus 2 is 14. And so one thing that's cool about this method is like, if you imagine me trying every single one of these and doing a full FOIL to check it, that's a lot of work. So I'm going through, this is getting a little frustrating. I haven't found anything, but if you look at these, I need these to add to a negative, and so you might have noticed as I was going through that this is a promising result. So that positive 10, actually, if I just switch these numbers, negative 6 times negative 4, that equals positive 24, and then negative 6 plus negative 4 does give me negative 10. So that means this is the line that I'm excited about. My two numbers are negative 6 and negative 4. So now what I want to do is take this original polynomial, 8x squared minus 10x plus 3, and rewrite that middle term using the two numbers I found here in step 2. So instead of minus 10x, I'm going to write minus 6x minus 4x. And then if you do this correctly, you are guaranteed that this will be factorable by grouping. So I can take out a 2x from these two, and then I can take out, let's see, what's common to these? There's nothing common to these. So what I can do, I could either just take out 1, but because of this minus sign, I want to take out, I'm going to factor out a negative 1. And I'll show you why here in a second. So then this 2x comes out, and what's left when I take that 2x out is the 8x squared. When I take 2x out of it, becomes 4x. Minus 6x, if I take 2x out of it, becomes minus 3. Now I take out minus 1. And what's left, if I take minus 1 out of minus 4x, I get just 4x. And then if I take minus 1 out of 3, I get minus 3. And what taking that minus 1 did is gave me these identical binomial factors. So that's what's going to allow me to finish this factoring by grouping. And when you're doing something like this, definitely pause, double check. Negative 1 times 4x, that is minus 4x. Minus 1 times minus 3, that is plus 3. So it does work. And now I can take this by grouping. I can take these binomial factors and bring them out front. So that 4x minus 3 comes out, and what's left then is my 2x and a minus 1, and that is my fully factored solution. Okay, let's take a look at one more. So here, this is one, and this looks pretty complicated and people can get kind of stressed out here, but if you look a little closer, you'll see this is an exciting one because I do have a GCF. My greatest common factor is y squared. So I can rewrite this as y squared times 5y squared plus 13y plus 6. And what that means is now I pretty much just have to deal with this part of the problem. I have to remember to put this y squared back in at the end, but really I can just deal with what's left after that factorization. So I'm going to say find my AC. So step 2, my AC is 5 times 6, so that's 30. Now I need to find those two numbers. I need numbers that multiply to 30 and add to 13. So I want to try some different numbers that multiply to 30. And you know, if you're really having trouble getting these figured out, you can just go through your calculator and try dividing 30 by things. Like if I do 30 divided by 1, that's 30. So like 30 times 1 is 30, and 30 plus 1 is 31. And then I could try 30 divided by 2 is 15. So that means 15 times 2 is 30. 15 plus 2 is 17. 30 divided by 3 is 10. So that means 10 times 3 is 30. And 10 plus 3 is 13. And that's what I wanted. So these are my numbers, 10 and 3. And now I can go into my step 4, take my polynomial, and I still have that y squared is still hanging out outside, but I don't have to worry about it until the very end. So like I have my 5y squared. Instead of 13, I'm going to write that as plus 10y plus 3y plus 6, because all I did was rewrote this 13y, and now I can do my factoring by grouping with this y squared still way on the outside. Those first two terms, these have a GCF of y, so I'm just going to take y times what? 5y Okay, I made a mistake. I'm just going to go with it and show you what happens. So I take out that y, and then I have plus 10. And then I want to see what's common to these two. These have a GCF of 3. So this is what might happen to you if you make a mistake on a problem like this. So I'm going to take out that 3, and what's left is y plus 2. So now you can see I want to factor by grouping, but these are not the same. And so what I can do, and maybe this happened to you in 6.1, this is the kind of thing that happens frequently to students, is, and I could panic, but I want to look at these. If I did this correctly, I am guaranteed that this will factor by grouping. So like, was my AC really 30? Yeah, that checks. That looks good. 13 is actually my B. I didn't copy anything wrong. I didn't miss a negative sign. 10 times 3, 10 plus 3, that's all good. So since this is all good, something must have happened up here. And what happened is this is not fully factored. So I can still take a 5 out of there. So I end up with, that y squared is still hanging out outside. Now I can take a 5 out of there. So what's outside here is 5y, and what's left in here is y plus 2, and that is just exactly what I need. So that looks really nice. Plus 3 times y plus 2. And so my y squared is still outside, and I can take my common binomial factor of y plus 2, and then what's left here is 5y plus 3. And so this isn't wrong, it's just not done. And so don't go in and erase things and cross things out really hard. It's all about just embracing. You might make some mistakes. You might have some slowdowns in this process. That is okay. It's all about just moving forward. So now I'm just going to remove those red parentheses, and my final answer is this, and this is fully factored. Okay, get in there, try some of these problems. This takes some practice. Come into the Math Center, come to my office hours, get help if this is something that you're struggling with. It is a challenging section, in my opinion. But it is a big deal, and it's going to keep being a big deal for all of algebra and all of calculus. So it's worth putting some time into now. Cool.